Okay, example, so we're gonna do the part 2 of it. We are on page 56, the middle bottom part where it says approximating solutions to inequalities, okay? So example number 7. Example number 7, we have x cubed plus 2x squared minus 1 is greater than or equal to 0. And it says solve it graphically. Okay, so graphically is the only way you're gonna be able to solve this because there is no other way. I mean, we'll find out later on. I will teach you how to do this algebraically, but right now you do not know how to do that. So if I graphed it, I'm going to end up with this, which is on page 57, top of page 57, right? I want to know where it's greater than or equal to 0, so I want to know where it's greater than or equal to 0. So it's going to be from here to here, or from here on over on this side over here. That's when it's greater than 0, right? Okay. So I would go ahead and use my trace function, find out these 3 points, okay? And then I'll be able to write the answer, okay? So it's basically just reading off the graph here, right? So that's how you do that, for example, number 7. Okay, so now we're gonna get into what is called the projectile motion. The projectile motion. Okay, this will come out again and again and again during this class. So you want to pay very close attention to this, okay? Easton, are you here? Okay, so in the middle of page 57, there is a blue box called projectile motion. Please read that. Okay, so if I stood on top of, or if I stood on the ground and fired a bullet straight up, okay, the bullet would go up, it would come down like this, right? And I'm standing right here. Okay, so it would go up and it's going to come down like this. We're going to assume that I'm not stupid enough that it's going to come down and hit my head and I'm going to die, okay? All right? So this is the equation that gives you the height of the bullet at any given moment. Okay? So the height of that bullet is going to be negative 16t squared plus the initial velocity. So that's the velocity that's leaving, the bullet's leaving the gun. And this here is the initial height, which would be what? What would be the initial height here?
Isn't it however high up the person is?
So how tall the person is, right?
Yeah.
If I'm standing on the ground, right? So how tall the person is, right? Because I'm going to go like this and I'm shooting, okay? All right. So this is the equation, okay? And on the first test, I will give you this equation. After that, you are not getting the equation, okay? So negative 16t squared plus v naught t plus s naught, okay? Anybody know where the 16 value comes, the negative 16 comes from? Does anybody know that? Anybody have a clue?
It's not gravity, right?
Who said that?
It's a rate.
Who said it was not gravity? Is that Caden?
Yes.
Okay.
Less,
So it
right?
has to do with gravity. Okay. What is the value of the gravitational acceleration? Anybody?
It's been a while.
Ah,
8 point something.
9 point, no,
nine
it's 9.8,
I'm here,
right?
9 point what?
Oh, 9.81
9.81. If you are doing in meters per
second squared. Yeah.
Okay. What if you're using British units?
16.
No. 32 feet per second squared. And it's negative. Well, why is it negative? Because it's pulling down, right?
Yes.
Pulling down, so it's negative 32, 50, but half of that. And that's 16 times 10.
Why are we using feet?
Why are we using feet? Because we live in the United States.
Meters are nicer.
If I told you that my height was 1 meter and 78 inches, 78 centimeters,
Which is common in my country.
which
I know how tall you are.
Okay, to the people in the United States, I'm gonna guess like maybe 5% would understand how tall that is.
True.
Meter and 78 centimeters tall.
So that's why we are using 32 divided by 2, which is actually negative 16 as a gravitational acceleration. Okay, that's where that comes from. Okay, so that's how you would solve that. So let's see if we can use that and do example number 8. Okay, so if you do example number 8, example number 8 says a projectile is launched straight up from the ground level with an initial velocity of 288. When will the projectile's height above the ground be 1152? So the height is going to be expressed as negative 16 t squared plus the initial velocity times t. Initial velocity was 288. And it said from the ground, so we're going to assume it's 0. And we want to know when this is going to be greater than 1152 feet. Okay, so this is how you set the equation up. Okay, so what's the very first thing I'm going to do? I'm going to divide everything by negative 16, right? So if I divide by negative 16, I'm going to get t squared minus, I'm not going to get the number here. What am I getting here if I divide it by 16? Did the book divide it by negative 16? Yes, they did. Oh, okay.
Negative 18.
18. So it's negative 18t, right? Now I have to switch this, correct? Why do I have to switch this?
Because you're dividing by a negative.
It's an inequality and I'm dividing by a negative number, so I have to switch this. Then 1152 divided by 16 is 72. This is what I get. So I get t squared minus 18t. Move the 72 over. This is what I'm trying to solve. Okay, so is there two numbers where this works? 418, that's not it. 2, no. And it looks like it's 6 and 12. Except this is negative, right? Because I was dividing by negative 16. We good? So,
Yeah.
So this is going to be t minus 6, t minus 12, 0, which means that if I were to draw the graph is going to look like this. I'm going to go 6 and 12, and I want to know when it's less than 0. Less than 0 between 6 and 12, right? Everybody see that? Between 6 and 12? Okay. So actually what's physically happening is this. I go like this, the bullet goes up. This is 1152. So it's going to hit 1152 as it's going up at t equals 6. And then it's going to go up and it's going to come down. And as it's coming down at t equals 12, it's going to come down. it's gonna hit 1152 again. But it's gonna hit 1152 when it's going up, and it's gonna hit when it's coming back down. Does that make sense? Do we understand that?
Yep.
All right, if I asked you, when does the bullet or the whatever the projectile reaches, when does it reach its maximum height? What would your answer be?
The middle point.
The middle point. So what would the time be at the middle point?
9.
9, correct? Because it's between 6 and 12, and it has to be symmetrical across the axis, correct?
Yeah.
But it's a parabola, right? So it's going to be when t is equal to 9 is when it reaches its maximal height, right?
Yep.
And I can also ask you, what is the maximum height? How would you solve for the maximum height?
We'll just put the x, which is 9, put it back in.
You would put the 9 back into the original equation, right?
Yeah.
Here you would solve here and these two terms, and you would solve that for when t is equal to 9, right?
Yeah.
I can also ask you, how long does it take for this projectile to come back and hit the ground?
Like time?
Yeah, the time.
Oh. I don't know.
Think about it. It takes 9 seconds to go up, which means it's going to take how many seconds to come back down?
9?
9. So in other words, at t equals 18 is when it hits the ground again. Does that make sense?
Yeah. Okay.
Does that make sense? So there are many, many questions involved with this. Now, this is one of the probably the most elementary questions, but I can also ask you, can also come up with questions like you're standing on the Grand Canyon and you're throwing a ball. So
Horizontally.
you're right here and you're up here, you throw the ball, it goes up and it comes down. When does it hit the ground? When does it come back to be equal? All kinds of different things.
Mr. On.
Yeah.
What if he throws the ball horizontally?
Huh?
What if he throws the
Oh,
ball?
what if he throws the ball horizontally? Okay, so we will talk about that. Okay? Because
Not
that
today.
introduces now the x versus the y coordinate. Okay, so right now, let's not worry about that. Right now, let's worry about the y portion. Okay? But yes, we will come and do the horizontal portion also. Okay? Because what's the difference between the vertical and the horizontal? What kind of gravitational acceleration is being exerted on the projectile in the horizontal position?
Isn't it the same?
0, right? Horizontally, the gravity is not going to do anything horizontally. It only does it vertically, right?
Won't it drag it down?
It's going to drag it down. Yeah, vertically, it's going to drag
Oh,
it.
I thought you meant if you throw it horizontally. My bad.
Okay, so if you threw it horizontally, what's it going to look like? You go like this. If I go from here, I think it's going to look like this, right? Correct?
Yeah.
Horizontally, right? So yeah, there are all kinds of different questions I can ask you here too. And we will talk about this. Again, we'll talk about this, okay? So I don't want to confuse you. But right now, let's talk about, just think about vertically what's going on, okay? We're done. Okay, so are there any other questions associated